we are given a binary search tree like this. In this binary search tree, blue arrow, blue arrow, blue arrow, blue arrow, blue arrow, blue arrow represent right parent-child relationship. So node 50 is connected with node 72 using blue arrow. Node 23 is connected with node 25 using blue arrow. So node 23 is right parents of node 52. Node 67 is connected with node 54 using blue arrow. So node 67 is right child of node 54. In binary search tree, red arrow, red arrow, red arrow, red arrow, red arrow, red arrows represent left parent-child relationship. So node 17 is connected with node 50 using red arrow. So node 50 is left parent of node 17. Node 12 is connected with node 17 using red arrow. So node 12 is left child of node 17. Node 18 is connected with node 19 using red arrow. So node 19 is left parent of node 18. We sort elements of this binary tree in ascending order and in descending order. Let's think about node 23. Node 23 and node 23. The successor of node 23 in ascending order is value 25. The predecessor of value 23 is 25 in descending order. So the successor in ascending order is the same the predecessor in descending order. Now let's think about value 17. Value 17 and this node. The predecessor of 17 in ascending order is 14. The successor of 17 in descending order is 14. So predecessor in ascending order is the same in successor in descending order. Suppose we are given value 17 in a binary search tree. We want to find the successor 18 in ascending order. So we create a function here like this. Binary node, it returns pointer, successor, ascending order. We take a node value int ref node value. In this case, value is 17. When node value 17 is given, we have to find this node first. This node's pointer will be REF node. REF means reference node. So we create auto REF node, and using this value 17, we find this node like this. This find REF node value. If REF node is valid, then we can find successor. Otherwise, we cannot find. We return null PTR. So at this point, we found reference node 17. We are trying to find node 17's successor in ascending order. So node 17's successor in ascending order, this is ascending order, is 18. Node 18 is here. We are in node 17. We have to find node 18. Node 18 is in this branch. This is right child of node 17. So we test if right child is valid like this. If REF node and right is valid, this 18 is minimum of this child branch. Once again, this 18 is minimum of this right child branch. So we return REF node and right minimum. In case of node 17, it has right child 23. So this operation holds because node 17 has right child. What if node 17 does not have a right child? For example, let's think about node 67. Node 67. Node 67's successor is 72. This 72. 72 is left parents. This is right parents. This is left parents. Successor over 67 is 72. 72 is nearest left parents of 67. So else if REF node has m parent, then we return REF node m parent nearest left parent. In this case, we have to pass REF node. Now suppose we are given value 14 and we want to find successor 17 in ascending order. We first find node 14. This node is REF node. Okay, so at this point we found REF node. Node 14 does not have left child. Okay, so this line does not hold. In this case, node 14, because node 14 does not have right child. So we try to find nearest left parents. Node 17 is nearest left parents of node 14. So node 14 has parents and has parents. This line hold, this part hold, because node 14 has parents 12. Through this 12, this is 12, node 12. Through this 12, we try to find node 17, nearest left parents. Now let's think about node 76. Node 76. Node 76 does not have successor in ascending order. Okay, 76 does not have right child. Okay, so this code does not hold. And node 76 has a parent. This is parent 72. In this part, it is node 72. And nearest left parents, this is right parents. Right parents, not left parents. Node 76 does not have a nearest left parents. This function returns null PTR because node 76 does not have successor. It does not have successor. This function returns null PTR. So this function works correctly. Now we want to find predecessor. Suppose we are given value 17. We are given value 17. Value 17's predecessor is 14 in ascending order. Node 17's predecessor in ascending order is 14. Here. This is left child. 14 is the maximum of left child. We initially find this node 17. It is called REF node. So I will create a function binary node. It returns pointer predecessor ascending order. It takes int ref node value. We have to find the reference node like this. Auto ref node this, find ref node value. If ref node is valid, we can find the predecessor. Else, we return null PTR. If value 17 is given, we find ref node, and we found ref node here. Then we test if left child exists. Okay, so if ref node m left is valid, we return ref node m left maximum, because left child's maximum 14 is predecessor of 17 in ascending order. So this part, if left child is valid, then we find maximum of left branch, in this case 14. Now let's think about value 54. Value 54's predecessor is 50 in ascending order. Value 54 is here, and it does not have left child. Okay, so in case of 54, left child does not exist. This part of code does not work. But value 54 have predecessor 50. Predecessor 50 is here. So 54, this is left parents, this is right parents. Node 50 is nearest right parents of 54. Once again, node 50 is the nearest right parents of node 54. So we have to find the nearest right parents of node 54 like this. Else if ref node and parent should be valid, then return ref node and parent nearest right parent ref node. So this function finds predecessor in ascending order. Suppose we are given value 18 and want to find the predecessor 17 in ascending order. So value 18 is this node. It does not have left child. Node 18 does not have a left child, so this part of code does not hold. Since node 18 has predecessor 17, predecessor 17 is nearest right parents of node 18. Once again, this is left parents, this is left parents, this is right parents. Node 17 is the nearest right parents of node 18. Node 18 has parents. This parents is 19. So this node parents is 19. Its nearest right parents is node 17. So this function returns node 17. Hi everyone, my name is Thomas Kim. Today is July 14th, 2019. This is my 58th episode about the modern C++ programming. This is also the last episode for binary tree in C++. I began to film about binary tree starting 7th of July, and today is 14th of July, so it took almost 7 days. And this episode continues from our previous episode 25th. In episode 25th, we learned how to find the successor and the predecessor of a node of a binary tree. This episode continues from this episode. So if you want to follow this current session, you should watch this video. Otherwise, you cannot follow current episode. Now start Visual Studio Code. In tutorial folder, you can find our previous source code 054 binary tree 09.cpp. Right click this file, right click, copy, scroll up, tutorial, right click, paste. Then rename it binary tree 10.058. Hit enter. You can close this file. Ctrl V. In our previous episode, episode 52, we created a function, find function, that returns the successor and the predecessor of a node. So Ctrl F, find, not this function. Okay, in this function, I will delete this part. This is for ascending order, finding successor. I deleted this part of code. Now here, we are finding successor in ascending order. I will simply copy this part of code. Copy and paste it here. I will arrange it like this. I have to arrange once again. Now here, this is value. So I will modify it into value. Okay, this is finding successor in ascending order. Now in this part of code, I will copy this part of code. From here up to here, I copied it and I will paste it here in this block. Paste. I will arrange a little bit like this, and this should be value. Okay, now in command prompt, we start command prompt. You should be in CPP extension tutorial folder, CL EHSC SDD C++ 17 058 binary tree 10 CPP FE binary tree exe. Hit enter. So you should build successfully. Now let's try with Clang compiler. Clang++ SDD C++ 17 058 binary tree 110 CPP O binary tree exe, hit enter. Clang compiler also works. We can cls binary tree, hit enter, then it gives some sample code like this. This is the sample code. I will copy this part of code. I copied and right click, hit enter. So we are finding successor of 19. The successor 19 in ascending order is not found because this value 19 is not in the list. Now let's try here, for example 8. Hit enter. This is ascending order. Value 8. Successor of 8. Successor of 8 is 9. In ascending order is 9. Okay, so it works. Now let's try with 16. Okay, 16. So successor of 16 in ascending order is 17. So it found. Now let's try in descending order. Descending, hit enter. So successor of 16 in descending order is 15. So this successor of 16 in descending order is 15. So it works correctly. What about successor of 6 in descending order? This is 6. Successor of 6 in descending order is not found, does not exist. It works correctly. Now let's try with predecessor. Predecessor of 16. Predecessor of 16 in ascending order is 15. Predecessor of 16 is 15 in ascending order. Now we can try with descending order. Descending, hit enter. So predecessor of 16 in descending order is 17. Predecessor of 16 in descending order is 17. So everything works properly. For your reference, if you want to know how to use this program, hit enter. Then it gives some descriptions and samples. For example, if you want to generate graph, you can copy like this, copy and paste, hit enter, then graph is generated. CLS, hit enter, copy the text including diagram, copy and start your web browser. eDoctor from this website, Ctrl A, Ctrl V. If you copy and paste, then this graph is generated. Here, V means value of node, okay? And H means height from the bottom. In case of leaf node, the height is 1. In this case, height is 2, height is 3, height is 4. Okay, in this case, height 1, height 2, height 3, because this is height 1, this is height 3, because it has 1, 2, 3 nodes, and this becomes height 4. I will post complete source code to my website, extension talkplayfun.com website. By the time you watch this video, you can click this link and download complete source code. If you unzip it in the CPP extension tutorials folder, you should be able to find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.